Hello. Right. Last time we talked about three-level lasers. The key points, electrons start in the ground state. With a pumping mechanism, we send the electrons to the highest energy level, E3 in this case. That's an excited state. They only stay there for about 1/10 millionth of a second and quickly drop down a level into the metastable state. We've now got quite a lot of electrons here, none here. We've got what we call a population inversion. In a different atom somewhere, perhaps an electron might drop down from energy level 2 to energy level 1 and spontaneously emit a photon. That photon can cause these electrons to fall down a level, each one emitting a photon. We've got stimulated emission of radiation and we've amplified our light. That's how a laser works. All of those photons are identical. There is a problem, however, with three-level lasers. That's this. We're trying essentially put electrons into this energy level by pumping them up here and letting them drop into this energy level here. The problem is, as this is the ground state, there will always be some electrons there. If you want to know why, you'll have to learn about quantum statistics. Sorry, you'll have to wait until you've done a couple of years of your degree. Right, so when a photon comes in that can cause these electrons to drop down a level, it could also get reabsorbed by these electrons here, which is not good. The best we could realistically hope for in this situation here is that we knock down 1, 2, 3, 4, 5, 6 electrons and 4 go up. We're only going to get 2 more photons out. For all of the effort we've put in to send up those 6 electrons, we'll only get 2 more photons. Not good. So what we can do is use a 4-level laser. E1, E2, E3, E4. It's essentially this level that's the extra level. This is the ground state. This is an excited state. This is a metastable state. And this is another excited state. Same processes are involved. We pump electrons from the ground state to the highest energy level. They fall down a level and they build up here. So here are where the electrons are. And again, there will always be some electrons in the ground state. Oh, look, there are no electrons here, and I've got 6 here. The population inversion is between these levels. In another atom somewhere, when the electron drops from this level to this one, a photon is emitted and it will knock down all 6 of these electrons. Here I've pumped up 6 electrons and I'll get 6 more photons out. 7 photons in total. There are no electrons here that could reabsorb the laser light. Yes! Woohoo! So this is much more efficient than the 3-level laser. Here there are electrons that could reabsorb the laser light. 4-level laser, there aren't. Any electrons that do drop into this level, they immediately drop down to the ground state. It's an excited state. They only stay there for 1/10 millionth of a second. So, the main advantage of a 4-level laser over a 3-level laser is electrons fall into an excited state. There are essentially no electrons that could reabsorb the laser light. Stimulated emission, when the electrons fall down, is much, much more likely than reabsorption of the laser light. Right, what I think you ought to do now is have a go at a question. Bear with me a second, sorry. Well, you've given this question a go on the 3-level laser. If you turn the page over, there's one on a 4-level laser. Give that one a whirl and then check the answers in my next video. And then I will be suggesting which of the exam questions you ought to be having a go at. Really, all of them. But I will only be going through the solution of some of them. You can check your answers on Moodle. I'll show you where that is in another video. So give that one a go and check back on the next video. Cheers.